This program offers a calm walk through the history of mechanical pencils and the ways lead sizes came to be. The story begins where graphite and metal meet and moves through slow changes in toolmaking and design. The voice here will mention simple inventions and gradual improvements rather than dramatic breakthroughs. Each step represents practical needs and modest solutions. People made holders for graphite fragments long before modern names existed. Craftsmen worked with small metal tubes and simple clamps so that marks could be renewed without a knife. Those early tools were utilitarian and often carried in pockets or desks. Over time, makers refined the methods for securing and advancing the graphite core. The result was a steady shift from fragile sticks to controlled, repeatable mechanisms. The long view shows many small choices that added up to convenient, compact writing implements that many people came to use daily. Graphite itself has an earlier history that informs the pencil story. Natural graphite deposits were discovered and used in simple ways before the idea of a pencil existed. Early users noticed that the dark mineral left clear marks on paper and other surfaces. Craftsmen wrapped short sticks of graphite with string or metal to hold them steady while writing. That pragmatic use is a direct ancestor of later mechanical holders. Over time, people learned to refine graphite, mix it with binders, and shape it into consistent rods. These refinements made the cores easier to handle and encouraged experiments with reusable holders. The relationship between a stable graphite core and a steady holder is central to what would later be called a mechanical pencil. The gradual improvements favored routine, predictable performance rather than novelty. Metal holders and small styluses appear in inventories and cabinets from earlier centuries. These objects were often simple tubes with a small clamp or threaded collar. They served practical needs for trades, offices, and drawing tables. Makers crafted them in brass, tin, and other common metals because those materials resisted wear while remaining workable. The designs emphasized serviceability and modest decoration. A metal sleeve that kept a graphite piece from breaking was already a convenience for daily use. Even modest variations in shape and grip mattered to users who wrote by hand for long periods. These devices gradually became more reliable, leading to fewer interruptions while writing. The focus was always on steady, repeatable marks rather than embellishment or speed. By the early 19th century, inventors began producing devices that deliberately advanced a core of graphite in a controlled way. One early patented design used simple screw or ratchet mechanisms to push the core forward incrementally. These mechanisms allowed a steady writing length to be maintained without frequent sharpening by blade. The idea was mechanical advancement rather than replacement of the whole assembly. Early patents and small workshops led to a slow diffusion of the concept among stationery makers. The mechanisms were practical and sometimes ornate, reflecting the tools and tastes of the era. Over time, the mechanisms were simplified to match mass production needs and everyday use. The result was a practical tool that combined portability with predictable markmaking. At the turn of the 20th century, firms focused on bringing mechanical pencils into wider use. New manufacturing techniques and materials made consistent parts easier to produce. One notable shift was the development of propelling mechanisms and clutch systems suited for different ends. Propelling pencils used internal pushers or ratchets to advance thin cores, while clutch pencils gripped thicker leads and released them when needed. Manufacturers marketed different styles for different users, from clerks to draftsmen. Commercial names and modest advertising made the tools familiar to more people. Production on a larger scale favored simplicity and reliability, factors that helped these pencils find a steady place in daily life. The market moved toward practical sizes and mechanisms that balanced durability and ease of use. Understanding mechanisms helps explain why lead sizes vary. Two broad families of designs shape the range of cores that are useful. One family uses thin, replaceable rods advanced by a delicate feed, which benefits from small diameters and smooth friction. The other family is built around a thicker core held by a clutch, which suits bolder marks and simple release systems. Each family evolved to meet distinct tasks, such as fine writing or robust sketching. Manufacturers standardized sizes within those families to simplify production and supply. The choices reflect functional trade-offs between fragility, feel, and control. The practical demands of manufacturers, retailers, and users pushed the common sizes into place over many decades. A handful of lead diameters came to dominate because they met ordinary needs consistently. Small diameters offer precise lines and require careful handling. Medium diameters provide a balance for everyday writing. Larger diameters suit drawing and heavier work. Makers settled on a few models that shops could stock without undue complication. Over time, those familiar sizes became expectations for buyers and designers. Materials science and improvements in manufacture also made thinner cores more reliable, expanding their practical range. The persistence of certain diameters reflects the slow alignment of supply, demand, and reliable production methods, rather than any single technical revelation. Alongside diameter, the composition and hardness of leads developed clear conventions. Manufacturers created graded ranges so that users could select firmer or softer cores depending on the task. Harder leads resist wear and keep a fine point longer, while softer leads yield darker, smoother lines. These conventions were adopted across markets because they helped users anticipate how a given core would behave. The grading language became familiar to people who wrote or drew for work. Simple, repeatable labels and consistent manufacturing allowed trades and artists to rely on predictable results. The system is practical and quiet in its purpose, focused on delivering an expected feel when the core meets paper. Standardization grew as manufacturers and users traded parts and supplies across regions. Metric diameters proved convenient for consistent production of thin rods, while larger leads retained more traditional, rounded measures. The spread of international trade encouraged common references and packaging that listed diameters and grades. Retailers found it easier to advise customers when standard sizes were common. Engineers and draftsmen appreciated predictable performance when specifications mattered. The practical effect was less variety in everyday inventories and more availability for common sizes. The quiet work of agreeing on dimensions and labels made the tools more dependable in daily use. Specialized needs kept a diversity of designs alive, even as some sizes became common. Technical drawing, fine art, and certain crafts continued to use thicker cores and clutch-style holders for bold work. Conversely, office and school supplies pushed for thin, neat cores that preserved a consistent line. Companies supplied refill systems to match those needs and added small conveniences such as erasers and retractable tips. These modest adaptations kept mechanical pencils relevant across a wide range of tasks. The coexistence of different systems reflects practical choices rather than aesthetic trends. Users allocate tools by function and habit, and manufacturers respond slowly to those steady preferences. Materials and manufacturing continued to improve, while the basic concepts remained familiar. New polymers and metal treatments helped reduce breakage and improve feed action for thin cores. Improved grinding and bonding techniques made leads less brittle and easier to handle. At the same time, many users preferred simple, familiar mechanisms that required little maintenance. The balance between advanced materials and established forms led to steady, incremental refinements. These refinements were practical rather than flashy, aimed at making the tool more reliable in routine use. The result is a wide range of quiet, dependable instruments that perform predictable tasks without fanfare. Looking back, the history of mechanical pencils and lead-size standards is mostly a record of practical adaptation. Small inventions accumulated over long periods, guided by the needs of writers, draftsmen, and makers. Standard sizes and grades eased supply and usage, while different mechanisms addressed different tasks. The timeline is marked less by dramatic turns than by steady refinement and pragmatic choices. The tools remained quietly useful, often unnoticed until needed for work or study. This quiet usefulness explains why mechanical pencils continue to be made and used in similar forms today, a result of many modest decisions rather than a single moment of change. Thanks for joining us for the history of mechanical pencils and lead-size standards. If you are still awake, Please stand by for our next program.